let us discuss about the half adder. The half adder can add only two input bits, let's say A and B, and it has nothing to do with the carry if there is any in the input. So if the input to a half adder have a carry, then it will neglect it and add only the A and B bits. That means the binary addition process is not complete, and that is why it is called a half adder. Now let us understand the circuit of half adder. You can observe there are two input A and B, each can provide a single bit, and in output there will be the sum, along with the sum there will be a carry output. To describe the half adder, let us first draw the truth table. You can observe the truth table. There are two input A and B, and you can also observe the combination, that is AB 00 followed by 01, after that 10, and at last 11. So these are the combination, as because there are only two inputs, so there will be four combination. And you can see in the output there are sum and the output carry. So there are two output. You can also observe in the diagram the sum and the carry. So you can see if the input AB is 00, you can observe the sum will be 0. If the input is 0 and 1, the sum will be 1. If the input 1 0, then also the sum will be 1. If the input 1 1, then the sum will be also 1. So you can observe that this is odd selector, as because if there are odd number of 1, then we are going to achieve high output, unless in other cases we will get low output. You can observe in the first row A and B both were 0, and we have achieved low output as 0, and in the last row you can see both the inputs were high, 1 and 1. So 1 plus 1 we have achieved 0, so that is low output. So you can observe in the second row and the third row there are odd number of ones. So in the second row 0 and 1, that means only one single one, that is odd number. In the second last row there are also input A was 1 as high input and B was 0, so that is odd number. So you can see if odd number of 1 is there as input, the result will be high. So in the carry, let us understand. See, if A and B are 0, then 0 plus 0, the sum is 0, the carry is also 0. You can observe if A and B are 0 and 1, then 0 plus 1, the sum is 1 and the carry is 0. And 1 plus 0, the sum is 1, the carry will be 0. 1 plus 1, the sum will be 0, but the carry will be 1. So why the carry will be 1 and the sum will be 0? All this thing we already have discussed in the binary addition. So I hope you understand why the sum is 0 and the carry is 1. So I think you have observed this is how the truth table has been designed. So if you consider the sum, then it is actually 0 1 1 0, and this actually represents the XOR. So A XOR B, that is the function that we can derive from this truth table. So we can observe sum equal to A XOR B, so that we have achieved out from the truth table. You can observe as because as per the laws of the XOR gate, if the odd ones are detected, then we are going to achieve the high output. So whatever we have achieved, we can observe in the second and the second last row there are high output that has been achieved from a single one, that is odd detector, and other row we can see there are two low output in the first row and two high input in the last row, both result to low output. So let us now talk about the carry bit. So you can observe the carry, so that is 0001. So you can see what will be the carry. So you can see 0 into 0, the carry will be always 0. 0 into 1, the carry is 0. 1 into 0, the carry is 0. So 1 into 1, the carry will be 1. So that result A into B, you can observe 0 into 0, 0. A into B, that is 0 into 0, 0. In the second row, 0 into 1, 0. In the third row, 1 into 0, 0. In the last row, 1 into 1, and that is 1. So that means if we work with the AND gate, so A into B, that means AND gate. So this is how we can represent. Let us now draw the circuit. So you can observe this particular logic of sum and carry are implemented through this half adder, and this is the circuit diagram. If you closely observe the half adder circuit diagram, A and B both were provided as the input. See, so to get the carry bit, as we can watch out in the function carry equal to A into B, and A and B both will be provided through the XOR gate to achieve the sum of A XOR B. So whatever we have derived the function, we have represented that to design the half adder circuit. It's very clear. You can observe both A and B are provided through the AND gate to derive the output of carry bit, and as well as both A and B are through the input pass out through the XOR gate to derive out the result of sum, that is A XOR B. Now let us discuss about the full adder. A full adder circuit is essential to most digital circuits that perform addition or subtraction. It is so called because it adds together two binary digits plus a carry in digits to produce a sum and carry out digits. The full adder is used to add three 1-bit binary numbers, that is A, B, and that carry C. The full adder has three input state and two output state, that is sum and carry. Let us understand the full adder in detail. You can observe the diagram of this full adder. There are three inputs A, B, and the carry. This is the carry of the previous sum, and when these three inputs are passed through the circuit, then the output will be the sum. Along with the sum, there will be the carry of this processing input. Let us understand how to draw the truth table. You can observe as there are three inputs, we will be having 8 combinations of zeros and ones. So we can observe the combination. Let us start with the first combination of input 0, 0 and 0. So the sum will be 0. 0 plus 0 plus 0, the result is 0 as sum. In the second row 0, 0, 1, the sum is 1. In the third row 0 1 0, the sum is 1. And in the fourth row 0 1 1, and the sum will be 0. Along with the sum you can observe the carry is 1. So in the fifth row 1 0 0, the sum is 1 and the carry will be 0. In the sixth row 1 0 1, as because 1 0 1, the sum will be 0 and the carry will be 1. And in the seventh row 1 1 0, here also the sum will be 0 and the carry will be 1. And in the last row 1 1 plus 1 plus 1, there will be the result sum as 1 and the carry will also be 1. Okay, now let us see the carry output A, B and C1. 0 plus 0 plus 0, the sum is 0 and the carry is 0. 0 0 1, the sum is 1, the carry will be 0. 0 1 0, the sum is 1, the carry will be 0. 0 1 1, the sum is 0 and the carry is 1. 1 plus 0 plus 0, the sum is 1, the carry will be 0. 1 plus 0 plus 1, the sum is 0 and the carry is 1. 1 plus 1 plus 0, the sum is 0 and the carry is 1. 1 plus 1 plus 1, sum 1 and the carry is also 1. Okay, now we have drawn the K map. Observe, we have drawn the K map for the sum. So you can see the input of the sum. So we have drawn the K map for the sum. So we have learned how to draw the K map in other lecture. So you can see the position of the first row 0A, 0B, 0CI and the sum is 0. In the second row 0 0 1, the sum is 0. In the third row 0 1 0 and the sum is 0. As in the sequential of the function value of sum, we have drawn this K map. So if you don't know how to draw a K map, you can watch from the playlist a video I have already prepared, and I have shown you there in detail how to draw a K map from the given truth table. So that is how I have drawn this K map. You can observe that video. There I have explained. In this particular video I am not going to explain how to draw the K map. So this is the K map for the sum. You can observe the high value 1, where 1 1, actually this is the odd detector. So if you closely observe the truth table, when there is odd number of high inputs, that is odd number of 1 as input, the result, the output is also high. You can observe. Otherwise all the outputs are 0. When there are all high inputs in the last row, you can observe all A, B and C1 is high, that is 1, and the output is also 1. And in the first row you can observe A, B, C, I, that is 0, that is low input in all three fields, and the output is also low, 0. Okay, but you can observe in second row, third row and fifth row, where there are odd number of high inputs and the output result that has been achieved is high, that is 1. So this represents that this is XOR. Now we can observe this diagram. This is the K map for the carry output. This is the carry output K map that has been drawn out here. So through the position of the output I have drawn this K map. Now if we derived out the function value from this given K map, we can observe this is how we have grouped the ones. We know how to group the one. This is how we have grouped the consecutive ones to draw out the function of the sum along with the carry. So this is the sum. What will be the sum? The sum will be A XOR B XOR Ci, that is carry input. And what will be the carry output function? To derive out the carry output function, what will be the formula that has been drawn out from this K map? That is BCI. You can observe BCI, the position BCI that has been observed through the group of 1 plus AB plus ACI. So this logic has been implemented in this full adder. One thing is that you can observe in some of the books the formula has been given, that is carry output equal to A plus B plus Ci, that is Ci common in bracket A XOR B. A XOR B. So how to achieve this formula? Let us observe. If we from the K map, if we just group the number of ones as I did, by doing this you will be not able to achieve this formula. So to achieve this formula we have to group the number of ones separately. Observe. See, this is how you have to group the number of ones. This is also correct. So in both way you can do this. In some of the books this formula has been given. So now I will show you how to achieve this result, this function from the given K map. So this is how you will regroup this number of 1, and after that just draw out the formula. See what could be the formula. This is carry output, that is equal to A plus B. You can see the last row, that is the second row, two ones, that is A and B, both the ones that has been pointed out, plus A naught B Ci. You can observe A naught B Ci, that is the third field of the first row, okay, plus A B naught Ci. You can observe that is the second field of the second row, A B naught Ci. So you can see how I have achieved this result. Now in the next step, see, I have taken Ci as common, A plus B, then after that AB plus Ci I have taken as common, because you can see Ci is common in both the parameter. So if I take Ci as common, then A bar B plus AB bar. So if we know, if the result is A naught B plus AB naught, that is representing A XOR B. So it easily we can prove that carry output equal to AB plus, if we take Ci as common, then in bracket we will achieve A XOR B. If we now draw the circuit diagram, so this is how the circuit diagram will look from the result. Just first watch out the function that we have derived out from the sum, that is A is equal to A XOR B XOR carry input, that is Ci. See, A XOR B, observe, see, this is two input A and B has been passed through the XOR gate, okay. has been passed through the XOR gate. Now see, whatever result that will achieved out along with the carry input will pass through another XOR gate. You can observe closely. The result of the A plus B through the XOR gate has been passed through another XOR gate along with the carry input. See the formula and match with the circuit diagram. And the result is what the sum we are going to achieve out. That is the sum equal to A XOR B, and then that result with the XOR Ci that has been represented through this circuit. And now let us watch out the carry circuit. How will we achieved the carry output from the circuit? Observe, see. So the A and B will be provided as input through the AND gate. See, we have taken two AND gate for deriving out the carry output. You can see the function carry output equal to A plus B. That means, carry output equal to A into B. So A into B means we are going to provide input from the AND gate, that is A into B. You can see we have taken an AND gate and we are providing A and B both as input through this AND gate. Plus, so we are taking another AND gate. Observe, so in this AND gate what we are passing through, observe, we are passing the carry input along with the result of A XOR B. The A XOR B what we have achieved from the sum A B that has been passed through the first XOR gate, from the first XOR gate. That result along with the carry input we are passing through this AND gate. Match this circuit with the function value Ci common and in bracket A XOR B. So that we are passing A and B through the first XOR gate, and that result we are passing through this AND gate along with the carry input, and both the AND gate output are passing through the OR gate, and that is what we are going to achieve out from this circuit as the carry output. I hope you have understood.